Alright, today we're going to talk about graphing of a quadratic equation in standard form, and this is the standard form of the quadratic equation, which is usually written as ax squared plus bx plus c, where a, b, and c are just, integers or fractions or something like that. And in order to do that, we need to start with getting the location of the vertex. Now, the vertex is the place that's at the top or the bottom of the U, depending on if it opens up or down. And you can find that by plugging in negative b over 2a, and this will get you the x value of the vertex. So a negative version of b would be a positive 8 because it's a negative 8 over here, over 2 times the value of a, which is 1. Now 8 over 2 is going to be 4, and that is the location of the vertex, the x value of the vertex anyway. In order to find the y value, what we do is we plug the 4 in for x, because these are the x values, and you can get any y value of any point by plugging in x. So we'd say, well, y would then be equal to a 4, which is your x squared, minus 8 times 4, which is your x again, plus 13. And we do some calculations. Y is equal to 16 minus 8 times 4 is 24, 32, I'm sorry, 32. And then plus 13. And we calculate that, and we say 16 minus 32 plus 13 would get me negative 3. Now this is the y value of my vertex, so my vertex is located at 4, negative 3. So over at 4, negative 3, I'm going to go ahead and put a dot. Now the axis of symmetry, since all quadratic equations are symmetric, goes through the vertex, and so it'll go straight up and down through there. We need to find some other points to the left and to the right of that to reflect across the axis of symmetry. So we're just going to pick some x values, so like 3 for instance. We'll go into there, and we'd say 3 squared minus 8 times 3 plus 13. 3 squared is 9, minus 8 times 3 is 24, plus 13, so 9 minus 24 plus 13 is negative 2. Negative 2 is the value that comes out when I plug in positive 3. So I would have a point positive 3, negative 2. And since that is on the left side of the axis of symmetry, I can reflect it across over here to the right side, and there will be another point that is the same distance away. Now it would be logical to pick another point to the left. We'll go with 2 since that's close to the axis, but not like already used. We can't pick 3 or 5. So we're going to plug in x is equal to 2. 2 squared minus 8 times 2 plus 13. 2 squared is 4 minus 8 times 2 is 16 plus 13. So we have 4 minus 16 plus 13. And that is 1. So we plugged in 2 and we got out 1. So we have a point at 2, 1. That, of course, is 2 away from the axis of symmetry, so if we go 2 away in the other direction, we'll have another point on the equation, and then my graph would come as a big, nice swooping U through all those points, and this would be the graph of y equals x squared minus 8x plus 13. Now, sometimes it's easy to find a nice point that can reflect. Let me just show you this one. We'd have the vertex is found by plugging in x equals a negative b over 2a, and so negative version of b would be negative 4 over top of 2 times, again, 1 is a, which would be negative 4 over 2, which is negative 2. That's the x value of the vertex. So I'm going to then need the y value, so I'm going to plug a negative 2 into the x in both cases. Make sure you're paying attention to your parentheses. It is a negative 2 squared, not a negative 2 squared. Make sure you put that in parentheses. Plus 4 times negative 2 plus 6. Now negative 2 squared is a positive 4, so be careful with that. Minus 8 plus 6, 4 minus 8 is negative 4, plus 6 is 2. And so my vertex is located at a negative 2, 2, which means that my axis of symmetry is going straight up and down through there at your vertex. Now there is a nice thing about this equation. We have the c value here, which is your y-intercept. That is always the y-intercept. On the last equation, c was too big to graph, so I didn't even bother doing it. But on this case, I have a point at 6, and that is where this u is going to cross the y-axis. And since I have that, and it's not the axis of symmetry, I can reflect the y-intercept across the axis of symmetry to get another point over here. That is also a point on my line. What we will then need to do is pick a x value that hasn't been used, which would be -1 or -3, because those are close to the x-axis of symmetry, but they haven't been used yet. So we're going to plug that in. I'll choose -1. X equals -1 will go in, and we will have a -1 in parentheses squared plus 4 times -1 plus 6. That's a +1 plus a -4 plus 6. And 1 minus 4 is -3 plus 6 is +3. So whenever we do that, we put in a -1 and we got out a +3, and so that is a point that's on my graph, which is 1 away from the axis of symmetry, so I can go 1 away on the left as well. We can then draw our U down through the 5 points that we have, and this is the graph of the line y equals x squared plus 4x plus 6.